also a hands-on session using Python on machine learning algorithm. And we had a special session on AI skill enabling the path forward. And in afternoon session of day 2, we had a discussion on pre-processing in machine learning and hands-on discussion in data cleansing, statistical analysis using R programming. In day 3, yesterday, we had a session on responsible AI, advancing real-world benefits, unsupervised machine learning, k-means algorithm, hierarchical clustering. And we had a session on introducing H2O flow and sparkling water, how to use deep learning algorithms for time series data for analysis. So for today's session, we will be having a session on graduating. Morning session will be on graduating from basic neural networks to convolution neural networks architectures by Dr. Sanjay Pawar, Professor UMIT, Mumbai. And afternoon session, we'll be having a session on CNN architecture for image classification by Dr. V. Sabdagirivasan, Manager R&D Medical Devices, Capgemini. Now, I would like to introduce our resource person, Dr. Sanjay S. Pawar. Sir has completed his BE in of Engineering Nanded, Electrical Engineering IIT Bombay, and PhD Networking from Department of EE IIT Bombay. He has 29 years of experience in teaching, research, and consultancy. And Sir is heading Usha Mittal Institute of Technology, Mumbai, since 2010. His area of interest are fifth generation wireless networks, software defined networks, small cell, fiber optic networks, machine, and deep learning in communications. He has several papers in international journals and conference to his credit. He has also mentored research proposals in the area of machine learning from Department of Science and Technology, Government of India. Sir has guided several students for PhD and master's program in the area IPv6 low power personal area net storage networks, software defined networks, and Dr. Sanjay S. Pawar is a senior IEEE member and IEEE and also held various positions in section and international level. He is a life member of IST. We are happy to have you here, sir, and we welcome you for this STTP program. Now I hand over the session on to you, sir. Thank you.
Good morning to all of you, and apologies for the delay of late by 5 to 10 minutes. And because in Mumbai I'm traveling, maybe some estimation of half an hour should be there, but sorry for that. And thanks for introduction, about my profile, and also thanks to one of my student who give or the institution which gave me an opportunity to give a talk on this latest area of research or interest, what we can say. And what is more important is though as I think MT also saying that this area is not now restricted only to the computer science or IT. I again being from a telecom side specifically working on a 5G, I literally see tremendous amount of resources or algorithms required for machine learning and deep learning for my solution to the 5G issues. I'm sure with the other departments, other domains which are there, they also might be needing this machine learning, AI, deep learning for solution to the problems actually. And okay, my voice is not clear. Okay. Am I clear now? Actually, I should have tested this before. Yeah, okay. So rather than, I think it's good. Actually, rather than using a microphone, I'm using directly the microphone of a monitor. It would be making me easy also to speak in a better manner. So I was just introducing those cases where what we would require more is a combination of a domain knowledge plus some kind of insights to this machine learning and deep learning algorithms actually. As many of them might be saying, I think there will be some kind of an application talks with respect to various domains here. What is more important is you should know the issues either from the research or applications point of view from the core domain, and also you should be able to utilize what kind of an algorithms from machine learning as well as AI you will be using for the solutions. Specifically, no, I'm an, as I said, I'm from technology domain. I'm specifically working from 5G point of view. I literally see tremendous area of work in the area of security issues actually. Though the topic which I'm using today is a combination of multiple things, specifically from the image processing point of view, but the algorithms or the thoughts process or the advancement has been seen specifically in these days from all these areas. I'm sure my issues and solutions in various areas will be sorted out by means of 5G, by means of AI and ML. And specifically nowadays, what we are going to do is in case of deep learning. Now, just give me a few minutes. Let me share my slides. Hope I'm audible. I'm properly audible. My voice is quite clear. Okay. Just a minute. I'm loading my slides. Are you able to see my slides?
It's visible, sir. Yeah.
Okay, again, first of all, I hope I'm audible and my slides are visible also.
Yes.
First of all, apologies for not decorating too much of the slides and because I was literally working too much on parallel. In fact, I had a couple of yesterday meeting throughout the day. But my intention here is to ensure from the engineering perspective point of view and from the what is called as a image processing perspective point of view, the introduction to this part actually of MCNN. So my flow will be, I think, I'm sure, I think our previous speakers might have gone through the basics of what is the neurons, what is the meaning of supervised and unsupervised learning, what is deep learning, convolution layer, polling, padding, and then I'll give some examples. Might be common with respect to all people. Almost this should be a first slide for all the deep neural network teaching or whatever the slides are there, which are comparing biological neural network with respect to our artificial neural network. So which consists of cell body, nucleus, dendrites, impulses, then how the information is carried and how the decisions are being taken. The same thing has been implemented here also, where you have inputs from various areas, which is being multiplied by means of a weight. You have input. So here, whatever is you're getting is W0, X0, multiple input cell bodies, some kind of activation function here, and then an output here. So this is a common, and everywhere the same thing will be used for making a decision. And this is what is just like a body, a single cell is there. Here in case of a neural network, this is what a single cell. A combination of all these things will make sure of what are the things. If maybe comparison of has been done previously, comparison of a supervised learning and unsupervised learning. So when we consider this, what we had was some kind of an input was there, some kind of an output was there. A black box is there, where we can say that this is an input X, this is an Y output. Multiple inputs are there, multiple outputs are there. So what we do is we train this model based upon what is the input and output. And whenever an unknown things comes into picture, I usually classify. So what I do is based upon some kind of a set of a data. So till time or till date, what I was using for AI or machine learning was in terms of a classification of a data. Either it is a text data or maybe some kind of social networking data, etc., etc. So what is the quality based upon this box is multiple things are decided. Maybe we can look towards again what would be the decision of this particular box. I think many of you might have also gone through the quality of this box, which depends upon some kind of some kind of an accuracy parameters that are defining your model. A basic neural network, which again consists of some kind of an input layers, kind of an hidden layers, what we can say that now. In case of a previous version, some box was there, and we were been training. I think many of the algorithms might have gone through till date with your previous sessions. And this algorithms, what you used to do is, okay, red color, throw here, black color, throw here, green color, throw here. This is what some kind of a classification was being made. I think you also might have gone through some kind of a basic of the things. How do we work, or what are the algorithms that are working from a linear classification and a non-linear classification. And this is one of the what we call as a multiple neural networks or multi-layer neural networks. Perceptron, I can say, where input data is given here, connections are here. Yes, have some kind of a specific purpose to take a decision, and might have seen this type of multi-layer perceptron working on various applications point of view. So first version was a simple classification from supervised and unsupervised learning. Second version was maybe a bit in deep with respect to multi-layer perceptrons, where each of the layer would have some kind of a specific function and take a call on this. As an example, what we do is in case of supervised learning, this is a box. We train this one. Okay, if this is a picture, we say this particular picture as if this particular thing has such type of picture that say it as a dog. If it is this, you can say some kind of a regression, or some of the examples may come into picture from the OCR characters. Specifically, when we learn today or when we understand CNN applications, one of the application is handwritten character recognition. Some of the slides I have taken it from net for these references, and most of the material again I have combined my own slides as well as some kind of a literature available on the net and books, and that's I'm presenting this. Now in this case, if you see comparison, I think the day things were being done previously by means of one simple box was there, which was taking care of a classifying. Either it is a number. A simple example is, let's have a number from 1, 2, 3, 4, 5, 10, and then I have a simple threshold of a 5. So 1, 2, 3 comes into picture. 1 or below 1, you can send upwards. Below above 5, we can say send upwards. So simplest possible classifications were there. Now to have an increase, or I think one of the, as I said, one of the parameter of quality of any of the model is it tells about what is the accuracy of your particular model. And in case of any of a machine learning model, we have seen that it purely depends upon multiple things. One thing is what is the data. Second thing is what are the algorithms which what I can say is terminate to certain decision within an error, etc. and so on. So instead of a single block, in case of deep, when we consider, there are multiple blocks which takes care of certain kind of decisions. Now each of this block is its own kind, its own decision, its own image processing application or image processing tool also, which works and then feeds to the next sequential layer. So we have seen as either in a multi-layer perceptron or maybe in case of deep learning, it's a sequential layers in some cases where one after another these things go into and then final decisions are. So our role here now is to identify what could be this block and how it could help resolving our day-to-day issues actually. This is again de-ionizing, maybe people who are from image processing background, etc. Those who are learned, you might be understanding what these things has to be done is a part of some kind of a pre-processing also. Now, when character recognition comes into picture, I think the people again who are from image processing, we are sure that we have seen before a machine learning, there are infinite number of algorithms and classifications which are used to classify the character is there or ABCD is there. We usually call that as a OCR. Now, but in this case, in the previous case, there were some kind of a limitations. Specifically, if I remember, I think principal component analysis is that, or maybe some kind of a, I can say, morphological image processing algorithms are there. So if you see there, you check how much accuracy we get in case of those cases. There are some limitations, or for example, we can go into the deep with this case of if I rotate certain things, whether still I'm able to identify those cases, or if not, there are some algorithms which have to run and then, so still a limitation or the things which I need to go to the accuracy level percentage, I may not be able to reach by means of a conventional image processing algorithms here. So that's the reason I think we are going into the deep network where we classify and then correctly. So analysis you might have seen nowadays with respect to the research contribution, the accuracy with which these digits are being classified is very high as compared to this case. Deep learning is about learning a feature. So in previous cases, this box was there. What I might have been done in previous cases is I would have checked either some kind of a principal component analysis. I would have checked whether how much is the white color, how much is the brown color. I would have checked what is the distance between these eyes, the distance between these nodes. So as in a previous, actually this is not a forum to discuss in detail with image processing, but these are the possibilities where it could let you know whether this is a dog or it is a face of Dr. Sanjay Pawar or it is something else or it is a tree or something. So what was necessary in this case? Conventional methodology of classifying this feature was a pre-processing. Again, from the concept, from the image processing point of view, I do some kind of a pre-processing where some kind of a noises are reduced. I will bring this particular image into certain particular format, particular size, etc., etc. Then I extract the features. So when I say features, also it is in terms of what is called as technical features. As I say, one is either eigenvalue, eigenvectors, some kind of a principal component analysis, or I define certain parameters with respect to some kind of a ratio, and those features might be there here. But the features here, so let's say take an example, because the feature we are considering from the image processing concept point of view and the features that we are considering from the deep learning point of view might be different. But let us understand that meaning of a feature is I'm just abstracting an information from this image and collect those particular information to take a decision whether what is this one. So the people again, my other experts will be detailed in will be and give those. So after feature extraction, I'm combining by means of an output of a layer by using certain decisions and then classifying, and then this is what the decision. This is what about some kind of a thought process are going in case of a deep learning. So it consists of what is called as a pre-processing, feature extraction, post-processing in terms of this one. So specifically, it is most critical for the accuracy point of view. These are what is called as the most time consuming in development. What is the best features? What next? Keep on crafting a better features actually. Can I get more and more features? Can I get multiple features? And let's learn how to extract those features from the data itself. So let's say this is a car. Now I want to detect, as might have seen, as case of a deep learning or machine learning. Nowadays we are working from the what is called as the live data, live information point of view. So I need to identify which is the car, or specifically when you go to the toll nakas nowadays, I think you might be seeing cameras, and specifically this number is also being tracked actually. So what is the intuition behind this one? Why we use a deep network? So these are the blocks that we are used to train and identify whether the detection of this particular image is what it is of its kind. And so there will be layer 1, layer 2, layer 3, layer 4. If you of deep learning, where I have said multi-layer perceptron, then we have shown some kind of what is called as a layers, where each of the layer has its some kind of a significance. So each block can be a trainable model where their compositions makes it highly non-linear system. The final layer output is probability specifically here of the final decision, and it is giving the output in terms of what is called the probability of what is being happening. So in machine learning, again, it is %, or in a simple single layer perceptron. Again, this is a revision so as to have a continuity between the thoughts what we will be learning, and then what has been considered the single possible cell. So single layer neural network, Z is equal to this Wx plus B, A is equal to Fy, where W is a weight parameter to be learned. That's what we are doing in case of machine learning. By input and output, we define what could be this, what is the weight parameters for various inputs. X is an output of a previous layer. F is a simple layer, nonlinear functional. Popular choices of output will be what is called as a ReLU. I'll go through that activations on that case. So these are the inputs. Okay, this is what input model. These are the weights, and these are the output models. So we call here as what is called as a neuron and some kind of a activation function. So function is there, X is the input, W is the weight, and by means of this is a simple single layer graphical representation of what we consider in case of a single layer neuron. Now in this case, when inputs are there, what we do is we have multiple sessions, and then errors are there. So what we do is input is there, output is there while a training session. So in each of this case, some kind of errors are there. So we feed this error back, and then the training happens in this case. So multi-layer neural nets with more than 2 layers are nowadays called also as a deep net. That is called a deep neural networks also. Also, user must specify the number of hidden units types of layer, and that depends upon what is the problem to be resolved, what are the problems to be resolved, and after what time, and up to what level also. Those number of layers are being decided. So let's say forward propagation. So computing the losses, this is an input, layer 2, layer 3, forward process propagation in this case. So let's consider the simplest example of a multi-layer process perceptron. The best example of, let's say, I need to detect whether this character is which character is there and so on. So it consists of one or more hidden layers based upon a conventional method. I usually is being used in case of previous multi-layer perceptron, the sigmoid activation function. So I have an inputs, I have some kind of activation functions, and I'm taking a decision whether it is A, B, C, or D, and so on. So number of training parameters become extremely large in case of, now we are just moving towards first initially.
Pawar sir, sorry interrupting you in between, sir. Sir, can you? Pawar sir, sorry interrupting you in between, sir. Can you turn off your video, sir? The voice is breaking.
We will see what are the issues with respect to this multi-layer perceptron. So we get an answer. It's not the case that we do not get an answer, but at what cost also. So multi-layer perceptron, as you have seen our diagrams, multiple inputs, multiple outputs, each of them connected to each other in certain way. So let's say in this case, number of training parameters become extremely large in case of this multi-layer perceptrons. Excuse me. So completely ignored in a previous case. So what kind of a data are there? So as I said, by means of image processing also we can consider this factors actually. But by means of image processing or morphological image processing, will I be able to understand? So in case of image processing, what I used to do is, if you remember, a character with certain things, and based upon that I used to take a decision. Am I audible?
Sir, your voice is breaking in between, sir. Sir, request in case you can turn off your video, the voice will become proper, sir. Hello?
Am I audible?
Yes, yes, now it's fine, sir. Fine, sir.
Hello?
Sir, it is fine now, sir.
I know, because what I am observing is, yes, I think, sorry. Actually, I thought it's not audible, and so in previous methodologies, we were not able to scale, modify, tune various characters and detections, or it was accuracy would have been degraded in such case of a scenarios. So topology of input data is completely ignored in case of a previous methodology. Okay, no, okay, let's I'll just go back to this. Now let me, so to avoid these issues, okay, so what we do is we go on kind of a what is called as a double issue again, we compare to the cases. We just introduce a parameter called as a convolution. Now when this convolution is very important, image processing point of view, convolving of an image, specifically in and impulse responses combination is given, and then based upon this convolution. So mathematical part of this is, if it is 1D infinite, alpha is equal to minus infinity to infinity. These are the inputs and these are the kernels now. So all of you understand the kernels. Again, once we'll go in deep with these cases, we'll go in deep with this. So this is 1D convolution. This is a 2D convolution. Let us visualize how it happens actually. So in case of a convolution operator,
Sorry for that temporary technical glitch. Dr. Pawar is back with us. Sir, you may start, sir.
Is my screen visible, please?
Yes, sir, it's visible, sir. It's visible
Okay,
and
sorry.
audible.
I'm extremely sorry for this inconvenience. Actually, issues with I can't comment, but apologies for this one. So in the continuity, this was with respect to a single ID. So I'm just showing this diagram in case of visualization of what could happen. And we can also imagine what we are extracting from the convolution point of view. So if this is a kernel, this is an input data. If I convolve this, you can a simple program you can write on a MATLAB. You will see that. So we can observe here that if some pattern matches with respect to this pattern, your kernel pattern matches with respect to the input signal, at that instant you will get a high. So this is what we are looking from the convolution. So if it is a 1D convolution, how does it happen? A simple programming actually. A kernel, you move through this window, whatever the output you are getting, these are the combinations of a kernel and output that you are getting.
I'll come next Monday.
To ensure that you'll be able to understand those cases. Input usually, in case of convolution, now we can see that input is usually a large set of data. Kernel is specifically a smaller number of a set of data inputs. A convolution operation produces highest value, as we have seen there. Convolution operation produces highest value where the kernel is most similar portion of the input. So if I go back here, so kernel shell will be giving the highest possible value where it is most similar portion of the input. So this property will be utilizing in case of a 2D operation, as we are dealing with the image processing and most of our convolution CNN operations are based upon 2D operations. It's an input IMN kernel KB convolution operations by means of 2-dimensional is given by this one. So again, same thing, it's single dimensional and multi-dimensional, they are the same thing here. CNN is usually not, so we are using this convolution network. These are usually finding the local and orientation selective nerve usual cells for the visual cortex point of view. This is what is actually how this name and term came into picture from convolution point of view. These are designed the network structure that implicitly extracts some kind of a relevant feature. CNN are specifically kind of a multi-layer network. Actually, many of the time the question is asked whether CNN can be a part of multi-layer network or multi-layer network can be a new multi-neural network can be a part of CNN. But usually they are of a multi-layer network, and spatial consists specifically from the computation point of view and as well as the result point of view. So, CNN is a feed-forward network which extracts some kind of a topological properties from the image. Actually, these are trained with the version of some kind of a backpropagation algorithms, which already might have gone through this one, and are designed to recognize some kind of visual patterns that directly are from the pixels with some kind of minimal processing. Now, how this is what I think some slides will be there, which is a comparison between a conventional multineural network and the CNN. CNN example can be used for the recognition of a handwritten characteristics. So usually we classify first, and then in case of CNN, we have a feature extractions. Now we'll see some kind of a properties also. It is also some kind of an example which is shift and distortion invariance. In case of a conventional image processing, we need to have this by means of extra algorithms which we could have taken a large amount of time, and specifically when it comes from the video point of view, the computation power would have been increased here. And then the classification. Now why convolution network? Because convolution network is able to successfully capture a temporal and spatial dependencies of an image actually. By means of what? By applying some kind of filters, or we also call sometimes this as a what is called as a kernels. Improvement of multi-layer perceptrons in terms of performance and accuracy. As I already said, the accuracy of a multi-layer perceptron is bit lesser as compared to the CNN, and the degree of invariance to the distortion in case of CNN is more. How it works, we'll see that one. So convolution layer is used instead of fully connected layers usually. So rather than using a fully connected layer, so if I drop certain things, I think you might have seen some kind of a dropouts also. Based upon that, we can get a convolution layer with some kind of a input specifics and so on. So if this y of f of x is some kind of fully connected layer with x as an input, y as output, w is set of weights, and f as an activation function, corresponding convolution layer is described by means of this, where S is a convolution operation between inputs and outputs. Now, what are the building blocks? Now we are going towards what is called the building block of the CNN. So CNN, it consists of a convolution layer. This is consisting of filters and kernels passed over an image. It also consists of what is called in the activation layer. In case of convolution layer, generates a matrix which is of a smaller dimension, runs to the activation layer to introduce some kind of a maybe some kind of a non-image to allow and train the network itself. Some of the examples of this activation layer, again, which activation layer and when it can be used is I'll just explain in the next slides. And one of them is what is called as a ReLU. Then it consists of a pooling layer. I think pooling layer, you might have gone through the image processing concepts, which consists of either addition, averaging, maximum. Those functionalities comes under the pooling layer, and this is one of the important factors to take a decision on certain or which gives some kind of a result which is giving a bit kind of an accuracy in case of a convolution neural network. And then after the pooling layer, we also have what is called as a fully connected layers. Its input is one dimensional vector representing the output of the previous layer, and output is a list of probabilities for different possibles. So I'll show the building blocks of this one, but these are some of the layers which are a part of convolution neural networks to take decisions. These are some of the examples. I'll show this one again. This is an image after activation. Then you are sampling the frames, subsampling, and then I'll go in deep with this example, but this is how we are converting from this into a serial single vector and the detection comes. Now, what is a convolution operation? Convolution layer, convolution neural networks requires a convolution operation. So what is the convolution operation here? Okay. So what is this operation is, if this is an input image, if this is a kernel, okay. So this kernel is moved through this image. For this position, you get an output here. A kernel, an input, and this is the output. So this is the convolution operation. What are the mathematical things we have done here? This is what that output is there. What is a 2D operation? So the same thing. So how does it work actually? You have an image, you have a kernel, you move this kernel through this image. So for this first position, you get this output. For the second position, you get this output. Third position. So if you imagine this kernel moving around these pixels, this is what the output you will be getting. And this is what is called the convolution operation in terms of image processing. And this we are using to solve our issues from the detection or the classification point of view. Now, when we consider image, always we have what is called the RGB combinations. So we work from RGB combinations. So this is what is a conceptual representation of or symbolic representation of a colored image, RGB, and is usually so. I will not have some kind of a diagram from 3G point of view. Better, 3 frames of a colors point of view, but I'll be showing only one color point of view, but imagining the similar cases are for the other colors. Now, how does it work? Let's say I have selected these are the slides that are images that are taken from the net itself. Actually, for a better understanding, I'm just showing you how the convolution layer works here. So this is a kernel. I'm moving this kernel through this image, and for each of this image, what is the output I'm getting is what is 4, 3, 4, 2, 3. So if this image or this kernel is convolved around this image, what is the output you are getting is this. Now this kernel, okay, is moved through this image in this manner, depth and height. So the same thing, if this is a kernel, this is an image. If I move this one, you can imagine what are the outputs that you are getting. So this is what is the convolution operation. On one part, what is the meaning of a convolution operation? Now for this, now we have used this one, this particular filters. Okay, this is a kernel. Now this is most important part. Kernels, sometimes filters, we use these kernels. Now to extract this information from an image, these kernels are being used. Let us have an example. Again, it requires some kind of a basic understanding of some kind of an image processing. And I hope most of the people have done some kind of an image processing. But let's say this image is there. Okay, though it is actually had changed its structure, and that's the reason that the blur is coming. But you can imagine from this point of view. If this is a filter used, this is what is called as an identity filter. I hope you understand what is the meaning of an impulse response. So if you move this filter through, if you move this filter, what are the output? I think it's not visible, but these are the only pixels. If I move through this image, you will get this output. When edge detections, I think you might have gone through this. So these are the kernels, okay, which decides what is the output actually, and extracting of an information are there. So each kernel, this will detect some kind of a edges. This will detect some kind of a edges, horizontal edges, vertical edges, sharpens, blurring, Gaussian blur. So when I use these filters to this image, these are the outputs. I'll show you some more examples also. So let's say best example that we'll be extracting specifically from the handwriting character recognition is detect same features of some kind of a different position in an image. So A is the character. This is a multi-layer perceptron. I have multiple filters here. So if I move these multiple filters through this character image, based upon what kind of a filter is there, I can get this feature. This feature you can understand, this is what is called as a horizontal edge detection, or some kind of a point detection. This is a horizontal edge detection, this is a vertical edge detection. So independently I am using this detections combining to find out what is the output, etc. How this works, this is an A convolve with the threshold, and output, when I convolve this A with the threshold, whatever the output I am getting is this one. So convolving, as in case of previous animated image I have shown this is what is happening actually. So convolution of this one gives you a single point. All the neurons in the feature share the same weights. Neurons detect the same features at different positions. It reduces the number of free parameters, and if neurons in the feature map fires, this corresponds to some kind of a template matching. So fires means what? Some kind of a template, that means small template which is in a kernel is matching with some kind of an image in case of a some portion of an image in that particular diagram of the image. Subsampling, so to get all these things, what you do is subsampling. Same concept comes into picture from the sampling theorem, etc. I'm reducing the samples to reduce the spatial resolution. Why do I need to reduce the spatial resolution? In some cases, I need to extract some information. I need not require some kind of a minute resolutions, a minute information, but on an average, what is the information with respect to this, whether it is a dark or whether it is a light one, and so on. So for that purpose, I can use this subsampling. So by reducing the spatial resolutions of the features of certain degree, it also comes in point of some kind of a shift variance. Now what we are doing is, by means of subsampling, we are trying to understand and make a decisions in spite of there is a shift in the variation shift in the character, my decision should not be changed. So these are the cases by means of subsampling. The layers reduces the spatial resolution for each of the feature maps. So if you see there here, various A's are there. By means of subsampling, these various outputs are there. So these are the results of some sampling in case of weight sharing. Now in this case, what is the full convolution layer? If this is an input, okay, these are the kernels now. Okay, so these are the kernels. Each kernel will give me some kind of output tensor, and this I am using. So this is the output of what is called as a convolution layer actually. So this is fed to a multi-layer perceptron to detect what is this kind of an image. So let's say what are the convolutions. So if this is an image, if this is a filter that I am using, what are the feature maps from this image I am getting is this one. So this is an image. I'm convolving this through. This is a kernel. So this is a feature map for this kernel and for this particular. So this is what is called as some kind of a visualization. What could happen to my image when I am passing through the knowing the operations actually. It captures the local dependencies of the original image. Two different filters generate two different feature maps. So if I want, as I said, in case of character, we have seen that if vertical edges are required, I should have -1, -1, -1, 0, 0, 0, +1, +1, +1. If I want a horizontal image, I should have -1, -1, -1, 0, 0, 0, and +1, +1. If I want to detect the edge or point, I can have -1, -1, -1, and center one is a +1. So these are different kinds, and based upon some kind of experimentation that you will be doing, you can take care what kind of filters and maps are being required and so on. And in case of a database, you can see there are standard filters available which are used for some specific purpose, or in case of some designs are also to be made with respect to the requirement. Two different filters generate two different feature maps of the same image. CNN learns from the values of the filters by its own during the training process. More number of filters, more features are there, and better is the recognition. So depending upon how many features, how many filters you are using, more features extraction will be there, and then work. Now, what are the size of a feature map depend actually? Just a minute, sorry. Hello? Hello? I'm in a lecture. Can you call me after some time? Give me a call. I'm in an online lecture, please. Sorry, actually, being a principal, like principal's phone, I need. I'm not sure about what thing. Sorry, 1 second. Sorry. Now, what about the feature map? So, what we had an image, we have a kernel. Now, there are some characteristics which decide some kind of a output also. So, what are those characteristics? What are the size of a feature maps? Size are controlled by 3 parameters. Which are those parameters? One is the depth, the number of filters we use for the convolution operation. So what do we extract? So as an example, I don't know whether I had it. So let's say I want to extract the eyes, I want to extract the ears, I want to extract the nose of an image, or to based upon whether it is an animal, whether it is an elephant or dog, I use these parameters to identify. So more the features, more the information. So depth, number of filters we use is used for the convolution operation. Stride, this is one again parameter which tells you about when you are moving your kernel from one pixel to another pixel. If it is a 1 pixel position, you call that as stride 1. If it is a 2 pixel position, you call it as stride 2, and etc. and so on. As the stride, larger the stride, smaller the feature information you will be getting and so on. And then third thing is called what is called as geo padding. So I think most of you, those who have done again the image processing part, you might be remembering why the padding is required, or specifically from the signal processing point of view. To get the information of all possible data that is present, I need to do the geo padding. And same thing happens here also. If I want to extract certain information from the edges, and my convolution operation might not permit because of the certain regions, because it is not giving some kind of an input, for this purpose a geo padding is done. So adding the zeros to the outside world, adding the zeros to the outside of the matrix, we get this information. So filters can be applied to the border elements. It allows to control the size of a feature maps. Adding zeros pads is also called as a wide convolution. So if you are adding a zero, it's a wide convolution. If you are not using a zero padding, a narrow convolution. But there are pros and cons. In case of widening, I'm taking the information. In some cases of an image and detection, if edges are very important or the boundary elements are very important, I need to add a zero. I need to do the zero padding. If information or the extract is at central place, then you need not have that. So these are some of the parameters. Output size is defined by n minus f, stride divided by stride plus 1. So if n is 7, length of an image pixel, this n by n size, f is a stride 1, stride 2, stride 3. So based upon this, output size is this particular. Okay, so these are taken from the slides actually. So this gives you some kind of a parameter in case of many times efficiency you calculate from the deep network point of view. So in this case, at what cost of an computational efficiency you are getting the results. This is what these parameters will tell you. This is what the meaning of a zero padding. Padding different dimensions are there, adding the pixels, top rows to the bottoms, to the columns left and right, filled with some values depending upon whether you are having a zero value or one or a maximum to 55. To make a resultant matrix of the same size, the padding for p dimensions of a beam matrix, this is what the equation comes in picture. This is an example of a zero padding to the common boundaries. Examples in case of filtering and padding, this is the calculations point of view. Okay, the same activation functions we use here and bringing again the same diagram to take care of from the activation functions point of view. So these are, I think many of you might have also gone that. These are some of the activation functions that we have used in case of machine learning to take a decision to classify certain things. Some of them are sigmoid. Previously, we were used for some basic classification. Tan hyperbolic, ReLU. We are using ReLU, rectified linear unit. Nowadays, we are also using some kind of a leaky ReLU also. So this is what's called as an, in case of a convolution operation, we use what is called as a, in case of some kind of an operation, it should not happen that we are getting a negative value. In case of an image, what is the meaning of negative value? So we define an image in terms of 0 to 255. What is the meaning of -2 or -6? To avoid this any calculation, these ReLUs are used in case of a convolutional layer actually. In some cases, we use this leaky ReLU that we'll discuss maybe if the application requires it. There are pros and cons from the activation functions from the sigmoid point of view, splashes the numbers from 0 to 0 to 1. So converts the number from 0 to 1. Historically popular since they have been nice interpretation for various firing rates actually. So it gives some kind of a better firing rate. Saturation neuron kills the gradient. Sigmoid outputs are not zero centered. Specifically, these are some of the mathematical parameters which gives you performance of a network. And exponential is bit compute expensively. Then tan hyperbolic scratches the number ranges from -1 to 1. So instead of 0 to 1, it is from. So here, if you see, the value is from 0 to 1. Here we are keeping the value from -1 to 1. It is now 0 centered. Previously, it was 0.5. It is 0 centered. Still kills the gradient when the saturation comes. ReLU, rectified linear unit. This is most of the time used for our convolution operations. Does not saturate. There's no saturation. So whatever is the positive input, it gives as it is. Okay. Whatever is the negative input, it restricts to the 0. Very computationally efficient. Converges much faster than the sigmoid and tan hyperbolic. Reason again, it is a non-zero centered. There are some applications, there are some reasons where we require a zero centric, and ReLU unit can't die actually because it is an infinite. Leaky ReLU does not saturate, computationally efficient, converges much faster, will not die. These are some kind of leaky where some kind of a negative positions are also being used. In practice, use ReLU before you carefully use your learning rates. Try leaky layout. In fact, when you are in my institute also now, if you ask today, around 60 to 70% of the project are in deep learning and machine learning. So I asked them many times, what happens if the activations are being changed? What is the result? So this will be a good example for all of you. If you are working on some kind of, what will be the results of an detection rate when you are using leaky ReLU, max out, etc., etc. But don't use the sigmoid specifically from the convolution point of view. Why use ReLU? ReLU is used after every convolution operation. ReLU is rectified linear unit. Output is equal to max, 0 or input. So either it is 0 or max. Represents all negative pixel values in a feature mapped to the 0. Purpose is to introduce nonlinear convent. Is here to introduce nonlinear convolution networks. Other nonlinear functions can be used such as tan hyperbolic, but ReLU performs better in case of detection as compared to others. This is what in case of pre-processing of a data, what you do. I hope just try to ensure I'm taking care within certain time period. When you process the data from image processing point of view, these are some of the examples that you require. If this is an original data, you are pre-processing it. It is a zero-centered. When you are normalizing this, this is the meaning of normalization of a data. Zero-centered of a data, this is the original data. Also, if this is the original data, this is the decorrelated data. This is white-turn data when all areas are of the similar. So these are some kind of a pictorial representation of a pre-processing of data, how it will look from the graphs point of view. So when I say a convolution operation, three different kernels are there. These are the figures, not pictures point of view, but when you see the convolution operation occurs here. So this is what the output comes into picture here. So these are the values when you convert this into. So here you see here a negative values is there. When a negative value comes into picture, if I use a ReLU, then this comes to 0. So three kernels for different operations. Whatever we are getting is the output. How do you extract? Objective to extract the features. So this is a kernel. This is the image. These are the zero padding. Okay, these are the zero padding. So when this kernel is moved through this one, you get this particular output. Okay, so this plays this one. So this is an extraction of a feature. Valid padding and same padding. Convolved features is reduced dimensionally as compared to it. If dimensionally is same, in case of same padding, dimensionality is same. When you are increasing, valid padding. This for the same padding. So when the padding is there, this is a convolution. If the same padding is there, this is what you get at output. Now let's come to the next important part, what is called as a pooling. Pooling layer is usually to subsample or reduce the dimensions. So this is one of the example what happens in case of a pooling layer. This is a matrix. This is I'm moving here, and what is the output you are getting is the output of a pooling layer. It reduces the spatial size of a convolved features because one of the comparison part of this pooling is as compared to this one is the computation power is too much reduced. And to reduce the computational power, and if I require only one pixel as compared to other information, then I do this pooling part actually. This is done to decrease the computational power required to process the data through the dimensional reductions. Also used to extract the dominant feature of an image. So what I do is, okay, this is a white color portion, extract this information. This is a ash color portion, extract this information. There are two types of pooling. There are multiple nowadays coming in, but majorly either a maximum pooling and the average pooling. The name itself indicates. Maximum pooling is is indicated by pool, takes an input tensor and gives to the output. CNN stacks convolution layer and pool layer. Convolution layer is always followed by the pooling layer. Pooling layer does not have a learnable weights actually. It's an average. So what is it? Maximum pooling. So if this is moved, so maximum of this particular portion is 20. So this 20 is coming. Maximum of this portion is 30. So this 30 is coming. Maximum of this is 112. So 112 is coming. Maximum of this is 20. So this miss actually it should have been 25. Miss one. So this is maximum. Sorry, this is 37. Okay, this is a maximum pooling and this is average pooling. So I'm taking average of this one. Average of this 30 plus 250. So here will be this particular average etc. So this gives an average. This is what a pooling operation. Let's see how does it work. So if this is an image, this gives a maximum pooling. This gives an average pooling output of that particular image. So convol operation. This is maximum pooling because the maximum value for the portion of the image convert into kernel. Average pooling returns average value of that image portion. Many times I require an average. What is an average intensity of that particular portion? So this gives them maximum pooling performs a noise suppression. So I'm using maximum pooling because there might be some kind of a noise in this particular area. If I want to reduce that particular portion, I use this one. I think go back again to the what is called as a image processing algorithm. So what is an average filters? Average filters you are combining. The same thing is happening here itself. Average pooling simple does dimensional reduction and noise reduction, noise suppression mechanism. So maximum pooling performs a better average as compared to average pooling. So this performs a pooling layer forms in the CNN depending on the complexity of the image and number of such layers may be increased depending upon the capturing of how many features you want to extract. And but also depends upon more computational powers, enables to understand the model in terms of features and classification. This is one of the example how it works. Sorry for again this. Actually, it is copied from one of the book, which is I think Kerkar, deep learning by means of using Python by Kerkar. This is the input. This is the convolution operations. This is the detector stage. This is the polling operation. This is the feature map. Detector stage is usually a simple nonlinear activation. Convolution, detection, these are usually applied in a sequence. Output is typically passed through the convolution or fully connected nets, and this combination is applied in a parallel, consuming the same input, multiple outputs. Means what? If I have to extract multiple features, same input image, multiple features, and give the output and extraction of this from there. This is given to the multi-layer perceptron at the output. So this is a convolutional layer. The output of this is given to the multi-layer perceptron. Then the training happens and the detection happens. So this is what the input works are there. Let me go through. Yes. So how do we design or some kind of a concepts with respect to designing? Fully connected layers, learning is possibly through non-linear function, that is the space. Images flatten afterwards. After the connection CNN, images flatten to the column vector. Then the feed-forward network and feedback algorithms are applied to it. And over the series of epoch models, the learning happens and the classification is done through the softmax. Actually, I missed that image. Actually, this is so input image, convolution, max pool, output volume, fully connected layer, nodes, then activation and the classification software. So finally, always this is softmax layer, which converts the probabilities into the decision making. So weights, how do I decide initialization of weight? If the weight in the networks are too small, then the signal shrinks as it passes through various layers until it's too teeny to be used. If the weights are too large, if the weight in the network starts too large, then the signal grows as it passes through each layer until it's too massive to be used actually. So there are some rules, regulations that the initialization weights are to be used. So it should not happen that you are using zero weight or highest weight and so on. There are some algorithms also which throw a weight. So all zero initializations not necessary. Small random nature, maybe in this case, draw the weight from the Gaussian distribution. As I said, there is some distribution with a standard deviation of this one where the n sequence output is given to the weights and so on. So this can be used, which gives you a better process. As we have seen, what is the important thing is in case of designing of a model is how do I terminate my algorithms in terms of a final weight. And initial values carry. So after how much time, how much epochs my output is reaching to the final value, this is also one of the criteria. Batch normalizations, initialization of neural network by explicitly forcing the activation throughout the network. It takes the unit Gaussian distribution at the beginning and training. Normalization is a simple differentiable operations. These are the batch normalizations comes into picture. Now I'll show you some of the examples before I end in giving you some kind of a visualization of what is a convolution network and introductory part. What happens at each level and the classification. These are some of the examples. This is a car. Now, if I have to extract low-level features from the car based upon various templates, this is what the low-level feature comes into picture. If I have to extract the mid-level features, these are the mid-level features coming. If I have to extract high-level features, for example, this relates to some kind of this part. Now, high-level, mid-level, and low-level. Can you visualize this? High level means there is a sharp increase in a change in a detection, or specifically value is changing from let's say 10 to 255 or 10 to 180. Low level feature means what? The value changing from 156 to 160. So that means what? On an average. Mid level, so based upon, so if I observe this intermediate frames, this is what you will be visualizing in those cases. These are the examples. This is for again some kind of a visualization of a part, what happens in a convolution layer. Similarly, in this case, these are the activations, and these are the things which have been decided how it happens. So usually when you run a convolution network, finally you get an algorithm, and by means of architecture you get all this information, and in a backend what you get is all these outputs. And I think by means of some kind of a architecture, if you want to get an output of all these things, you'll be able. So it's really visualized. Or again, many times I'm telling to our students that when you write a program, when you work on these programs, always before the output comes, at each stage you should be able to visualize. So when visualization comes, I still feel again when you're doing some kind of a convolution network, when you're writing a filter, you should be able to visualize for that particular filter when it is in this particular region, what could be the output. So this is an example. What happens? A car is there, a convolution layer, rectified ReLU, convolution layer, pooling operation, convolution layer, pooling operation. And this is what output. Some kind of an architecture is used to detect whether this image is car, a truck, an airplane, a ship, or an horse. Actually. So this is what the layers comes into picture. I'll answer another example. So as many times we have seen that these examples are used, or specifically convolution neural network are being used in case of character recognition, or specifically handwritten character recognition. So this is an input. I have a convolution layer here, output of a convolution layer. This is how I'm converting the convolution output into pooling. Now you can see the size of the image has been changed. So in case of pooling layer, I'm changing the dimensions here. You can see here. So here is maybe let's say 255 by 255. It has been reduced to 50%. Then another pooling convolution layer for some kind of activation. Pooling layer, converting this into an what is called as a vector now. And this vector, based upon input or output, the training happens here, and the final detection comes into it. So this is an example. What happens here? Convolution layer, pooling layer, fully connected layer, and then output comes into picture, whether it is 0, 8, etc. etc. This is a live example which is available on some net also, using a net, which gives you a visualization. If I write a program for character recognition and for various kinds of an image, this is again from AT&T, their own architecture. So let's say you can see here the characters are there, and I'm able to detect the character here. Okay, this is a plain simple thing. This is the case where I should say that even if my size go on changing, I'm able to detect that particular number. This is the case where when my position goes on changing, I'm still able to detect that particular number. If my orientation goes on changing, I'm still able to detect it. And this is what we do by means of what is called as a convolution neural network. Now, in fact, I think the people who are going towards the deep learning, you can see that this again is also a part. It itself, convolutional network itself, doesn't give a fully output results, etc. But it is a part, and then connecting, or specifically one of the examples, I think might have heard this LSTM or maybe RNN networks. Unless and until there is a combination of convolution neural network and the RNN network, you will not be able to have some kind of applications such as a captioning of an image, etc. And so on. And then, as I said, this is a what is called the first stage in case of a deep network, where I can make a decision to have a correct decision to identify those cases. So this figure, I think, is quite clear. You can imagine what thing might have happened at the back end in case of designing, but this could be a better portion of imagination of for all possible combinations, and be able to take a decision. With respect to hello.
Sir, you are connected again, sir.
Okay. Clear? I have done with my presentations. Hello.
Thank you so much, sir, for your insights. It's our immense pleasure to thank you for sharing.
Was I audible?
Yes, sir. Yes, sir.
Okay. I thought because it was showing some kind of a mute, so I thought when I was explaining. So till the end.
Yes, sir. It was audible, sir.
I'll be happy to answer any questions.
Yes, sir. From the participant sides, if any queries, please you can clarify with sir. Any queries from participants? Participants, your queries, please. Okay. So really, it's our immense pleasure, sir, to thank you for sharing your valuable ideas on this very wonderful session on neural networks, convolution neural network architecture. And you have shared all the major concepts of CNN within a very short time. So that a live example to understand the concept of CNN using the LetNet, using to recognize the character was very inspiring. And I thanks a lot for a wonderful session, sir. Thank you, sir. Thank you, sir. Any queries from participants?
I hope my intention of introducing this area was clear. Yeah. Hello.
Yes, sir.
Yeah. Done with or any questions are there?
Till now, no queries from participant side, sir.
If done, then?
Sir? Yes, sir.
Okay. Thanks a lot.
Thanks a lot.
Thanks for inviting again, and it was a pleasure interacting with you.
Yes, sir. Thanks a lot, sir. Thank you for your valuable time, sir. Thank you.